All right, everybody, we're going to walk through logistic regression here using the sample data set of students with high school GPA, math scores, race, categories, gender, their course grade, their first course grade in math, and whether or not that is translated as a pass or a fail. So first thing you want to do, of course, is look at your data and understand it. High school GPA is 0 to 4. But the likelihood of any of these students having a 0 GPA is pretty low. Race categories, gender, and then the grade itself. For this purpose, we can assume that grades of anything less than a C, so D, F, and W would get a grade of 0 or rather fail, the 0 being that they did not pass. However, C and above would be an indicator that they did pass. So remember, in logistic regression, we're predicting the outcome of a binary variable. So two options, either something happened or something did not happen. The action that we're interested in measuring is what we assign the 1 to. So we want to know what's the likelihood of students passing a first math class based on a couple of factors. And so we've assigned the score of 1 to passing the class. So now that we've taken a look, you notice that we've got a couple blanks here. So that'll impact our total sample. But I think overall, we've got quite a few records. Yeah, over 500, 521. Now, some of those may have blanks. And if those blanks happen to be in variables that are being used in the analysis, then it will reduce the sample. So the first thing we want to do is go to Analyze Regression, Binary Logistic Regression. And remember, the pass-fail is our dependent variable, 0 and 1. So we'll move that over into dependent. And in this first block, because we're going to take multiple steps here, we're going to do a hierarchical binary logistic regression model. The first thing we want to do is maybe take into account gender. And then we can go to the next block and bring gender back in, and then also add in ACT math scores, right? So gender and ACT math scores. And then in the third block, we'll bring in gender and ACT math again, but also high school GPA to see what kind of impacts it has. Now that we've got all three of those in here, we do have a categorical variable, so we'll need to define what that is. And I like to keep the reference category for hypothetical purposes, theoretical purposes. We'll use last, which makes females our reference category. So when we interpret the outcome, how likely it is for male students to pass in comparison to females. So continue if we're good with that. Also, what we'll want to save is our predicted value for probabilities and group membership, as well as standardized residuals, including our Cook's distance. So this will, again, help us if you go back to your notes. You will see that we want to look at Cook's distance of less than 1 and standardized residuals of very few above 1.96, but none above 3. So that's why we're going to save both of those. And then hit continue. And go to options just to see if there's anything we might want. We can do classification plots. And then hit continue again, and then paste if you want to save your syntax or OK. So the first thing you might notice is we have quite a few missing cases in this processing summary. And so total number of cases is 522. 233 were included in the analysis. And so what we want to know is kind of what was not included. So let's go back and just see what may not have been included in the analysis. Definitely missing the GPA there, but also look at all these students that did not have a first math course in their first year, or first term rather, I think it is. So it makes sense, right? Our initial assumption of 521, you would have very quickly realized, well, actually we only have 232. because all of those don't have a math score, in addition to the one student that didn't have the GPA, right? So that's okay. Still have more than a couple of hundred, so I think we should move on. First thing we want to look at is our beginning block 0. Our beginning, oh, and also look at our categorical variables. Yeah, pretty evenly split here between gender. Beginning block 0 tells us that without any utilization of this analysis, we could just assume that all students failed and be right about half the time, 50% of the time. So what we want to do is we want to make sure that as we add variables to this model, that we increase our likelihood of being correct. So moving into block 1. Block 1 shows that our model is not statistically significant at this step. Remember, this is just including gender, right? And so, as you might expect, our pseudo R-square values are also very low. Our effect size means that we're not explaining hardly any variance here. And our overall percentage only went up by about 0.9 points. So very little change. Now in block 2, this is where we introduce the ACT math score. At this step, it is statistically significant. We're able to explain about 4% of the variance, 4 or 6, depending on which one you look at. But our overall classification has gone up dramatically by about 6% just with one variable. So that's good to know. Next, in block 3. Block 3 is where we brought in high school GPA. And the significance value goes even lower. Our chi-square value goes up even greater. We're able to explain about 15 or 20% of the variance. And look at that. Our improvement on this model by including high school GPA means that we're able to predict 2/3 of the variance in the model based on these factors alone. So let's try to interpret the variables in the equation. Remember, the exponent of v is the likelihood of the effect or the outcome occurring. So males are less likely than females, right? Because it's less than 1. And so that's not a significant predictor, but nonetheless, just wanted to say that out loud. Math scores, again, aren't significant and don't really change much, but look at that. If you, for high school GPA, if you have a 1 unit increase, which means if you have a 2.0 GPA and I have a 3.0 GPA, I am 6.7 times more likely to pass my first math class because I have a higher high school GPA. And with that, I'm going to go ahead and stop this recording. Let me know if you have any questions.